Water has always defined civilization. Every textbook, every documentary, every archaeology course tells you the same thing. Humans settled near water sources, learned to manage them over centuries, built irrigation slowly, upgraded infrastructure gradually, and eventually, after generations of trial and error, produced the sophisticated hydraulic systems we find throughout the ancient and medieval world. That's the accepted framework. It's logical, it's well documented, and it works. Until you look at the scale of what they actually built. Because here is where the numbers stop making comfortable sense. In the Roman Empire, at its administrative peak, engineers constructed aqueducts that delivered an estimated 300 to 1,000 liters of fresh water per person per day to the city of Rome. Modern cities, with electric pumps, pressurized piping, industrial filtration, average somewhere between 150 and 300 liters per person per day. Rome, built with manual labor using gravity-fed stone channels across mountains and valleys, was delivering water at a rate that modern infrastructure has only recently matched, and in some cases has not exceeded. That's not a gap. That's an inversion. This video explores historical interpretations and unanswered questions found in existing records. It does not present definitive conclusions. But let's stay with that number for a moment. The Aqua Claudia, one of Rome's 11 major aqueducts, stretched over 68 kilometers. It was constructed between 38 and 52 AD. It required precise gradient calculations, the channel maintaining a consistent drop of roughly 3 meters per kilometer, sustained across terrain that included hills, valleys, and unstable geological zones. The margin for error in this kind of engineering is almost non-existent. A calculation error of even a fraction of a degree over 68 kilometers compounds into a catastrophic failure of flow. The Romans maintained that gradient without satellite surveying, without digital modeling, without modern theodolites. Some historians argue this was simply the product of centuries of accumulated practical knowledge. That Roman engineers learned by doing, corrected failures, and refined methods generation by generation. That explanation is credible. It's the standard explanation. The difficulty is that the refinement timeline doesn't always match the output. The earliest large-scale Roman aqueducts, the Aqua Appia, built around 312 BC, were already functionally sophisticated. Not experimental. Not preliminary. The first major attempt at Roman water infrastructure arrived effectively complete. Historians note this, acknowledge the puzzle, and typically attribute it to influence from earlier Greek and Etruscan hydraulic knowledge, which is a reasonable answer. Except that when we examine Greek and Etruscan water systems from the preceding centuries, we find similar patterns. Sophisticated output appearing early with limited visible developmental trail behind it. This is not an accusation. It is an observation about the archaeological record. And it is an observation that applies well beyond the Mediterranean. In the Indus Valley, at sites like Mohenjo-Daro and Harappa, dating to approximately 2500 BC, excavations have revealed something that genuinely complicates the conventional developmental model. These cities had standardized brick-lined drainage systems. Not just drainage, covered sewers. With inspection ports. Running beneath streets that were themselves laid on a grid. The sewers were connected to individual household latrines, which were in turn connected to a city-wide waste management network that directed effluent away from the population center. Let's be precise about what that requires. A covered sewer system with inspection access points, connected to household sanitation infrastructure across a planned urban grid, requires standardized building materials, city-wide planning coordination, an understanding of waste and contamination, the engineering logic of flow management, and the political or social infrastructure to maintain it over time. Mohenjo-Daro demonstrated all of this simultaneously, at its earliest excavated layers, not at its peak. The sophistication appears at the beginning. The conventional explanation is that the Indus Valley civilization had a longer pre-urban developmental period that simply hasn't been found yet. Possibly. But the physical evidence that has been found doesn't show a gradual build toward the drainage system. It shows the drainage system. This pattern, sophisticated hydraulic infrastructure present early, without a clear developmental ramp, recurs across enough regions and time periods to invite examination. In ancient Persia, the canal system, underground sloping tunnels that transported groundwater from highland aquifers to lowland agricultural zones, was in active use by at least 1000 BC, and some estimates push the earliest examples further back. A canal isn't improvised. Constructing one requires surveying the subsurface geology, calculating the correct angle of descent over kilometers of underground tunnel, ventilating the work as it proceeds, and coordinating teams who are often working in sections without direct communication. The longest known canal stretches over 70 kilometers. To build it, someone had to understand not just where the water was, but where it would be, how the water table behaved seasonally, how it responded to altitude, how to access it without triggering collapse. Who taught them that? The standard answer is accumulated generational knowledge, early experimentation, gradual refinement. And yet the oldest canals that have been examined don't show the rough characteristics of early experimental engineering. They show mature technique. Across ancient China, hydraulic infrastructure at the scale of the Dujianjian irrigation system, completed around 256 BC, still functioning today, reflects engineering logic that manages sediment, flood control, and water distribution simultaneously through a single structure with no moving parts. It works because of a deep understanding of fluid dynamics applied precisely to that river, that terrain, that seasonal cycle. The system's designer, Li Bing, is credited by historical records. But the sophistication of the solution he implemented suggests a body of knowledge he was drawing on, not inventing. Here is the question that starts to feel unavoidable. Each of these systems, Roman aqueducts, Indus Valley sewers, Persian canals, Chinese flood management, appears in its respective culture at a level of sophistication that implies either an extremely rapid internal development with no surviving evidence of the learning curve, or the presence of prior knowledge that entered the record without its origin being clearly documented. Historians, archaeologists, and engineers have noted these anomalies. The explanations offered are thoughtful and grounded in available evidence. But the evidence also carries gaps. And those gaps appear consistently in the same place, before the sophistication. The water was being moved. Precisely. Early. What is less clear, and what the record in multiple regions does not fully resolve, is where the knowledge to move it that way first came from. Let's move forward in time. And westward. Because if the anomalies found in Rome, the Indus Valley, Persia, and ancient China were isolated, products of specific regional conditions, specific cultural advantages, specific geological luck, then the pattern would stop there. The gaps in the developmental record would belong to those civilizations alone. Interesting perhaps, but not systemic. They don't stop there. In medieval Europe, the conventional historical model describes a period of reduced urban sophistication following the collapse of Western Rome in 476 AD. Infrastructure declines, cities shrink, the large-scale hydraulic systems of the Roman period fall into disrepair or are gradually forgotten. This is the accepted picture, and for much of Europe, the archaeological record supports it. Aqueducts crack. Bathhouses go unused. Population centers contract. But then something happens in the 11th, 12th, and 13th centuries that the standard narrative describes as a gradual re-emergence of urban infrastructure. New towns are built, trade routes expand, and water infrastructure, mills, channels, urban conduits, begins reappearing. This is presented as reconstruction, medieval engineers relearning, rebuilding, rediscovering. Some of what they built, however, doesn't look like rediscovery. In the city of Bath, in southwestern England, the Roman baths sit atop a natural hot spring that produces approximately 1.17 million liters of water per day at a constant temperature of 45 degrees Celsius. The Romans built a sophisticated lead-lined reservoir, a drain system, and a bathing complex around this spring by roughly 70 AD, within decades of arriving in Britain. The engineering precision required to capture and manage a geothermally active spring, which produces water at constant pressure and temperature but must be controlled to prevent flooding and scalding, is not trivial. The Romans managed it cleanly. When medieval builders returned to the site centuries later, they did not rebuild the Roman system. They built around it, on top of it, through it, incorporating elements of the original Roman infrastructure into their own construction. In some areas, the Roman drainage channels were still functional. In others, medieval construction inadvertently disrupted Roman systems that were more sophisticated than what replaced them. That detail, medieval construction disrupting infrastructure that was more sophisticated than what replaced it, is documented in the archaeological reports from the site itself. It is not an interpretation. It is an observation from the physical record. This is not unique to Bath. Across England, the remains of Roman-era water infrastructure, aqueducts, mill leats, drainage systems, urban conduits, have been found beneath and around medieval and early modern construction at a consistency that has prompted significant academic discussion. In some cases, medieval engineers appear to have recognized and reused Roman channels. In other cases, they appear to have been unaware that what they were building through had already solved the problem they were trying to solve. The question this raises is not about intent. It's about gap. If Roman hydraulic knowledge collapsed with the Western Empire and medieval engineers rebuilt from foundational principles over centuries, you would expect a clear architectural and engineering record of that rebuilding process. Early medieval attempts that are rough, experimental, gradually improving toward more sophisticated solutions. In some regions, that record exists. In others, the progression is difficult to trace cleanly. Infrastructure appears, canals, mill systems, urban water channels, at a level of functionality that implies more than elementary knowledge, without a clear documentary or physical trail showing how that knowledge was accumulated. Now move further west, to the American continent. Pre-Columbian hydraulic engineering across Mesoamerica and South America presents anomalies that have been studied, acknowledged, and imperfectly resolved by archaeologists for decades. At Teotihuacan, the city that dominated central Mexico between roughly 100 BC and 550 AD, excavations have revealed a sophisticated drainage system beneath the city's main ceremonial corridor. The system managed stormwater runoff across a city that, at its peak, may have housed over 100,000 people. The drainage infrastructure ran beneath streets that were themselves precisely leveled. A city plan that required surveying capability and coordination across a build area of approximately 83 square kilometers. Teotihuacan's builders remain officially unknown. The city's name is an Aztec designation meaning roughly, the place where the gods were created. The civilization that built it left no deciphered written record. What it left was the infrastructure itself, and that infrastructure in its hydraulic components shows the same characteristics seen elsewhere. Functional sophistication present early, with limited visible developmental evidence preceding it. In the American Southwest, the Hohokam people constructed an irrigation canal network in what is now the Phoenix Basin of Arizona. At its maximum extent, this network stretched over 800 kilometers, delivering water from the Salt and Gila rivers to agricultural fields across a desert region. Some estimates suggest the canal system irrigated over 40,000 hectares. The Hohokam were building at this scale by roughly 600 to 900 AD, and the canals they left were so well surveyed and so precisely graded that when Phoenix developed as a modern city in the late 19th and early 20th centuries, American engineers found it more efficient in many areas to simply clean and reuse the Hohokam canals than to survey and dig new ones. Read that again carefully. Modern engineers, with surveying equipment and hydraulic modeling, looked at canals built by a pre-Columbian desert people somewhere between 1,000 and 1,400 years earlier, and concluded that the existing channels were precise enough to reuse. This is documented. It is in the engineering records of the Salt River Project, one of the oldest federal reclamation projects in the United States. It is not a fringe claim. It is infrastructure history. And yet the Hohokam left no written explanation of their surveying methods. No engineering documents. No developmental records showing early canal attempts that were rough and gradually refined. The large-scale, precise network appears in the record without a visible apprenticeship phase behind it. Across the United Kingdom, this same structural question resurfaces in a different register. The drainage of the Somerset Levels, a low-lying wetland region in southwestern England, involved large-scale channel and ditch management that predates the Norman conquest. Archaeological investigation of the Sweet Track, a raised wooden walkway built across the levels around 3800 BC, revealed evidence of organized landscape management at a scale that implies coordinated labor and planning across a significant geographic area, far earlier than the conventional model of organized British hydraulic management suggests. What's notable is not that any single one of these examples is inexplicable. Each individually has a proposed explanation. The discomfort comes from the consistency, the way the same structural gap appears across regions, across centuries, across cultures that had no documented contact with one another. Infrastructure before the population that would demand it. Precision before the known refinement period that would produce it. Systems that appear in the record already mature. Some researchers studying these patterns have noted that the consistency itself, the repetition of this particular anomaly across such varied contexts, begins to suggest something worth naming. At some point, patterns require language. Not conclusions. Not verdicts. But language, a way of grouping observations so they can be examined together rather than filed separately under different civilizations, different centuries, different academic departments. Science does this. Medicine does this. Archaeology does this. When a symptom appears repeatedly across unconnected cases, researchers eventually give the cluster a name, not because the name explains it, but because the name allows the conversation to become more precise. In certain corners of historical inquiry, some academic, some popular, some sitting in the uncomfortable space between, a label has emerged for the cluster of anomalies this documentary has been tracing. That label is Tartaria. It's important to be precise about what that word means in this context, and what it does not mean. In conventional historical cartography, Tartaria, sometimes spelled Tartary, is a real geographical designation. It appears on European maps from the 13th through the 19th centuries, used to describe the vast interior of the Eurasian continent, roughly the land stretching from the Caspian Sea eastward through Central Asia, Siberia, and into the regions bordering China. On maps produced by French, British, Dutch, and German cartographers across several centuries, this region is labeled with varying degrees of specificity. Great Tartary, Independent Tartary, Chinese Tartary, Muscovite Tartary. The designation was used by serious European geographers and appears in encyclopedias, atlases, and diplomatic correspondence. It is not an invention of modern internet culture. It is a documented historical term. What has happened in recent years is that this cartographic label has been borrowed by a loose, informal network of researchers, amateur historians, and content creators, and applied as an interpretive framework for exactly the kind of infrastructure anomalies this documentary has been examining. Under this framework, Tartaria is used not as a specific civilization or empire with defined borders and rulers, but as a placeholder label for a proposed prior knowledge system, a body of hydraulic, architectural, and engineering understanding that some researchers suggest may have been more widely distributed across the ancient and medieval world than current historical models account for. This interpretation is not accepted by mainstream archaeology or academic history. That is a fact, and it matters. Professional historians and archaeologists who have examined these claims have raised significant methodological objections. The absence of a developmental record before sophisticated infrastructure, they argue, is more likely a reflection of what has survived and been excavated than evidence of knowledge arriving from outside the documented timeline. Organic materials decay. Early experimental structures are often built over. The archaeological record is, by nature, incomplete, and drawing systemic conclusions from its gaps is professionally considered an overreach. That critique deserves to be taken seriously. It is made by people who have spent careers working directly with primary evidence, and it is grounded in the genuine difficulty of arguing from absence. And yet, the researchers who apply the Tartaria label to hydraulic anomalies are not, in most cases, making claims about a hidden empire or a suppressed civilization. The more careful among them are making a narrower and more specific observation, that the consistency of the pattern, infrastructure sophistication appearing early, across disconnected regions, without a visible developmental trail, is statistically unusual in a way that the incompleteness of the archaeological record alone may not fully explain. One interpretation is that the gaps are purely archaeological, that the developmental record exists, and we simply haven't found enough of it. This is the mainstream position, and it is defensible. A second interpretation, offered by researchers working at the edge of established academia, is that knowledge transfer occurred across ancient and medieval trade and migration routes in ways that are not fully captured in surviving records. That hydraulic engineering techniques moved between cultures, from Persia to Rome, from Central Asia westward, through channels of contact that predate the documented diplomatic record. Some historians have explored versions of this argument within conventional frameworks, tracing the movement of engineering knowledge through the Islamic world's preservation of classical texts, through Silk Road cultural exchange, through the movement of skilled craftsmen following military conquest. This is legitimate scholarly territory. It doesn't resolve every anomaly, but it addresses some of them. A third interpretation, the one most closely associated with the Tartaria label as it circulates in popular historical inquiry, is that the sophistication visible in early hydraulic infrastructure implies a prior knowledge source that has not been identified, named, or mapped within the current historical consensus. Not a civilization in the conventional sense. Not a hidden empire. But a distributed system of technical knowledge, possibly associated with the populations and cultures of the Eurasian interior that European cartographers vaguely designated as Tartaria, that influenced hydraulic engineering across a wider geographic and temporal range than current models account for. This interpretation has not been substantiated by archaeological evidence. It is a hypothesis, not a finding. The researchers who advance it are working largely from the same gaps and anomalies this documentary has described, not from new primary evidence that overturns the existing record. What makes the conversation worth having is not that any of these interpretations is provably correct. It's that the anomalies themselves, the Roman delivery rates, the Indus drainage systems, the Hohokam canals, the Persian Khanate, the Bath disruptions, the Somerset levels, are real. They are in the record. They have been documented by credentialed archaeologists working within mainstream institutions. The observations are not fringe. The interpretive frameworks built on top of them vary enormously in rigor and restraint. The Tartaria label, as it currently functions in popular historical discussion, is a container. It holds a set of questions that the mainstream record has noted but not fully resolved. Whether that container is the right shape for those questions, whether what it implies about prior knowledge systems is proportionate to the evidence or far beyond it, is a judgment each viewer, each researcher, each reader has to make by engaging with the primary evidence directly. What the hydraulic record shows, across cultures and centuries, is that water was being moved with precision before the knowledge to move it that precisely is clearly documented as having existed. The pipes are in the ground. The channels are still graded. In some cases they are still flowing. Where the full knowledge to build them came from, and through what hands it traveled before it arrived at the civilizations we study, that question sits still open at the edge of what the existing record can answer. And the water, as it always has, keeps moving through structures whose origins remain, in the most precise historical sense, incompletely understood.